Today we're going to be talking a little bit more about measurement systems and going over a couple more examples, and I apologize, I didn't really have the board in view there. Particularly talking about the metric system and then a few ways to convert between metric system stuff and so-called imperial units, which is what you're probably used to working with if you grew up here in the United States. Now, one of the nice things about the metric system is that a lot of the units are related to each other by powers of 10. And because they're related by powers of 10, well, that makes it very nice to work with them in a decimal system of numbers like we tend to work in. Now, the way that they are related by these powers of 10 is that if you're given any kind of a unit, you can make other units out of it by just putting a prefix on the unit. So a good example of this that you might be familiar with already is the unit of meters. So 1 meter is a unit of length. It's approximately like 3.3 feet. So it's a little bit more than a yard if you're wondering how big it is. But this is the basic unit of length that's used in the metric system. Now, the thing is that from meters, which are represented with the symbol M, we have other types of units that we can create as well. So, for example, we have the centimeter, which is symbolized with cm, and this has the relationship that 1 centimeter is 1/100th of 1 meter. Sorry, my head's blocking everything here. We can also form the kilometer, usually pronounced kilometer, just because we kind of shorten the whole word together. But the prefix here is kilo, and so we get the kilometer, which is represented km, and the kilometer has the relationship that 1 kilometer is equal to 1,000 meters. And in fact, 1 kilometer is, oh gosh, what is it? It's something like 0.6 something miles. I don't remember the exact conversion here, but it's more than half a mile. It's not as big as 3/4 of a mile. Anyway, now the thing is that this centi here and this kilo here, these are just prefixes that you can attach in metric to any given unit. So for example, if we're talking about units of weight, grams, which are represented with G, this is the basic unit of weight that is used in the metric system. Technically, it's a unit of mass, so if you're talking to a physicist, they'll want to be really careful about the difference between mass and weight. But grams is how the people in metric system measure mass. But you've probably heard of the kilogram, which is represented with kg, just like kilometer was represented with km. And this has the relationship that 1 kilogram is equal to 1,000 grams. Well, you'll notice that 1 kilometer is equal to 1,000 meters. So you get this same kind of relationship, and that's the basic rule. If I have a unit in the metric system, whatever that unit might be, whether it's meters, whether it's grams, whether it's some other kind of unit, because of course there's lots of different units for measuring different kinds of things, if I put the prefix kilo on it, that just means it's 1,000 times whatever that base unit happens to be. The same thing goes for centi. So we don't use it very much because 1 gram is actually a fairly small weight. A gram is actually very, very tiny. 1 kilogram is about 2.2 pounds. So you can see that 1 gram is actually very small. I believe the relationship comes out to be that it's about 28 grams is equal to 1 ounce. So, you know, an ounce is pretty light. So 1 gram is really, really light. But if you're measuring some very, very tiny quantity of stuff, you might want to work with even smaller units of weight. And so you can form the centigram, which is going to be represented as Cg. And this would have the relationship that 1 centigram is equal to 1/100th of a gram. And you can use these prefixes, like I said, with any unit in the metric system. Now, there are other prefixes that you want to be aware of here. So let's just kind of go through the quick list here. If you want to change things by a factor of 1 million in the metric system, then the prefix that you would use is mega, and the symbol that you would use is a capital M. If you want to change things by a factor of 1,000, then that's kilo with a prefix of K, which we already talked about in the example of the kilometer and the kilogram. Then this one is not used nearly as much, but they do have a special name for changing things by a factor of 100. This is called the hecto, and it is represented with the symbol H. I don't really ever see this one being used, except I think sometimes it's used in surveying and issues with properties like hectares, hectacres, 100-acre plots of land or something, possibly. But mostly I've never seen this really used. You can change things by a factor of 10 using deca, which apparently I can't spell. It's D-E-K-A here. And this has the symbol DK. Now, once again, I've never really seen this used very much, but it is out there. Then, of course, you can just have the regular unit itself, so we won't bother writing that down. You can change things by a factor of 1/10 using the deci. And this is symbolized with just a lowercase d. Then you can change things to 1/100th by using centi, which puts a little c in front of whatever you are using. And then you can do 1/1000. This is called the mille, and is represented with a little m, a lowercase m. Notice we used an uppercase M for mega and a lowercase m for milli. So you can kind of remember this because the big M makes things bigger and the small m makes things smaller. And then if you wanted to, you can do 1/1,000,000th. So that would be called a micro. And this usually has the symbol mu. This is a Greek lowercase mu. So you might see things that are being measured in micrograms or micrometers, micrometers, 1/1,000,000th of a meter. That's sometimes used if you're working with very small things, in computer engineering and stuff like that. And there's actually a few that are even smaller. There's the nano unit and the pico unit, which I will let you guys look at that in your book. I'm not going to bother writing it down. I don't think it's something you're going to deal with very much when you're talking about units that are used for veterinary purposes. So to give you an example of using this kind of stuff, if I were to tell you, okay, I want you to convert 3 meters to decameters, we could say, well, the thing that we know is that 1 decameter is going to be equal to 10 meters. And that gives me a conversion ratio. Now, if I want to convert this, think back to what we did last time with converting units. We want to cancel the meters and be left with decameters. So that means that I need to take this equation here and convert it into a ratio where I say I get 1 decameter per 10 meters. So this ratio is a conversion ratio. Remember, a conversion ratio is a ratio involving units that is equal to 1. And I'm going to erase this stuff now. Hopefully you guys have this written down. Well, now all I have to do is take the 3 meters and I can multiply that by my conversion ratio, 1 decameter over 10 meters, the meter units cancel, and I am left with 3 over 10 decameters, which is 0.3 decameters. One of the nice things about working in decimal is that all of these prefixes, are not decimal, in metric, I'm getting ahead of myself here. One of the nice things about working in metric is that these prefixes just change things by powers of 10, which means that in a decimal system, changing the units by changing their prefix is just going to move the decimal point. Remember, multiplying or dividing by a power of 10 just moves the decimal point around, and that's really all that we do when we convert things in the metric system this way. And this makes working in the metric system much more convenient in some ways than working in the imperial system that involves things like inches and pounds and ounces and all this kind of thing. Now, of course, one of the questions that we then have is, how do you go back and forth between things like a measurement in the metric system and a measurement in the imperial system? This is something that you're going to have to do rather frequently. Depending upon what you have to do, of course. Sometimes you'll have everything in the metric system and then everything works out nicely. Sometimes everything's in the imperial system and then it's not quite as nice because you can't just move things around using rules for moving the decimal point, but it's still fine. But sometimes you have to convert back and forth between them. Maybe you have a patient and you have the weight of the patient in kilograms, but the medication that we're going to use tells you something that involves pounds. So then we need to get from kilograms to pounds. And a few conversion factors for the metric system to the imperial system, which is also called, I believe, SI for standard imperial or something like that. I don't remember exactly what it stands for, not super important. A couple of the conversions that you can remember for this are that 2.54 centimeters is equal to 1 inch. And from this, we can get a couple of different conversion ratios, right? Because I can divide both sides by 1 inch, or I can divide both sides by 1 centimeter, and that is going to give me whatever conversion I need. In fact, I believe we did an example of this last time, where I said at the end, okay, and now you can just throw this into a calculator and be done with it. Another conversion ratio that it's a good idea to memorize is this one. So 2.2 kilograms is approximately equal, not 2.2 kilograms, what am I saying? 1 kilogram, I apologize for that. 1 kilogram is approximately equal to 2.2 pounds. It's actually something like 2.204 if I'm remembering correctly, but for most purposes, you can probably say, we just need the 2.2. If you really need it more accurately than that, obviously you can look it up, or you can memorize it if you want to. But usually if you're just trying to get an estimate, memorizing this much is fine. And if you really need precision, then you want to go and, of course, look it up. So this is another important conversion that we can use. And let's take a look at actually using this conversion in a specific case. So let's suppose that we have a dog, and let's say that the dog has a weight of 12 kilograms. We want to know what is the weight in pounds. So give me a moment to write out the problem. And then we can go ahead and do this. Well, if I want to convert this weight from kilograms into pounds, then I need a conversion ratio that is going to cancel the kilograms and leave me with pounds. Well, what is that conversion ratio going to be? If I divide both sides by kilograms, I get a conversion ratio of 1 is equal to 2.2 pounds over 1 kilogram. This is the conversion ratio that I want to use. So I'm going to take my 12 kilograms here, and I'm going to multiply this by 2.2 pounds over 1 kilogram. And when I do that, the kilograms are going to cancel here and leave me with 12 times 2.2 pounds. And this is going to be, let's see, so a couple of different ways that we can do this. Maybe the easiest way to do it is to say that this is going to be equal to 12 times 22 divided by 10 in pounds. So we'll convert it into a fraction problem. Now 12 times 22 would be 120 plus, 240 plus 24. So that would come out to be 264. So this would be 264 over 10 in pounds, and that is going to be equal to 26.4 pounds. Remember, of course, that this 2.2 is approximate, it is not exact. So if you really needed this to be perfectly exact, then we would need to look up what is the relationship to further decimal places here. Unfortunately, like I said, it doesn't work out to be something super neat and nice, but usually the 2.2 is good enough. All right, so let's now take a look at another example, and I will ask you guys to try to do this yourselves first, and then watch my solution. What if I wanted to go the other direction? So what if I have a dog and let's say that this dog weighs 44 pounds, and we want to know how much is the weight in kilograms. So pause this, take a moment, and then come back and we'll do the solution together. All right, so I'm going to do the same kind of idea as we did before. I'm going to say, okay, I want to start with 44 pounds. I want to cancel the pounds, and I want to end with kilograms. So I need to take my relationship, 1 kilogram equals 2.2 pounds, and I need to get something, a conversion ratio, that has pounds in the denominator. So I'm going to divide both sides by 2.2 pounds, and that gives me 1 kilogram over 2.2 pounds equals 1. So this is my conversion ratio. It has pounds in the denominator, and it has kilograms in the numerator. So that is exactly what I want. Now, if I multiply using this conversion ratio, I'm going to have 1 kilogram over 2.2 pounds. Pounds will cancel, so that's good. And that's what we wanted. That's the reason I did it this way, right? We set up this conversion ratio to make sure that the pounds would cancel out. This leaves me with 44 divided by 2.2 in kilograms. And of course, 44 divided by 2.2 is going to come out to be 20. So we get that this dog is approximately 20 kilograms. I say approximately because, once again, this is only an approximate equation. It really, the exact relationship involves some more decimal places and things like that. But this is good enough for most purposes, and so we're going to use it that way. Now, just to give you a little bit of a preview of the sorts of things that we're going to do next with these kinds of conversions, when we are working with higher dimensions, for example, things like areas or volumes, well, in those cases, you're going to need to use the conversion ratios for things like lengths, but you need to use them repeatedly. So, for example, suppose that I wanted to convert 144 square inches to square feet. Well, this is something that we don't necessarily know offhand. Like, how much is 1 square foot in inches? Well, what we can do is we can say, okay, 144 square inches. Inches squared, you can really treat the units just like you would treat constants. So you can really think of this as inches times inches, which means that if I want to cancel out those squared inches, I need to multiply by the conversion ratio from feet to inches. So that's going to be 1 foot per 12 inches. And I need to multiply by it again, because the first inch cancels out with one of these inches, the second inch cancels with the second inch. And then it also leaves me with feet times feet, which is actually feet squared. So in this way, you see that the units, they really do behave just as if they were numbers or, constants, really, that we're just symbolizing with these letters. Anyway, when you do that, you're going to get that this is equal to 144 divided by 12 times 12 square feet. And of course, 144 over 12 times 12 is just 1. So this is just 1 square foot. Now, what we're going to be looking at next week is going into more detail about how can you build more complicated conversions like this for things like areas, volumes, other types of things where the units are sort of composite units. They're not just the simple basic unit like an inch or a meter or a mile or something like that, but something that we've built out of other things. Well, you can build the conversion ratios as long as you know the conversions for those basic units. And you do it just in this way. You ask yourself, how do I cancel these units and get the units that I want to end up with? All right, so I'm going to ask you guys, let me take a look here at the book. So try to take a look at the chapter on the metric system and the chapter on the apothecary and English measurement systems and converting between the two of them. So this starts on page 135 in your book, and it keeps on going. Well, it's the next 2 chapters, really. So try to take a look at those. Now, there are a lot of conversion ratios here in your book that I haven't written on the board here. The reason I haven't written them is because I'd basically just be writing down that stuff straight from the book. So you may as well just look at the book there, take a look, practice the problems, and of course, please let me know if there's any sort of questions that you might have. And don't forget that you guys have a quiz. I think I accidentally didn't make it available to you, but it is available now. So you should be able to go do it, unless you're watching this after Friday, in which case it'll already be closed. Anyway, I will talk to you guys next week.